Welcome back to the Calculus series, and in this episode, we're going to be looking at the product rule. Now, we're already familiar with the rules thanks to the sum rule being the derivative of a sum, and that is the sum of its derivatives. And we also know the constant product or scalar rule, where we can factor a scalar out of the derivative entirely. So the derivative of a times a function is a times the derivative of that function, where a is just a constant like 2, 3, pi, etc. Naturally, we'll want to know what the derivative of a product of two functions, let's say f and g, is. We could start by writing down the derivative using the standard formula, noting that we do x plus h for both the f and the g in the formula because we have to replace all the x's. So both the x on the f and the x in the g. With no direction in sight, it would be nice if we could turn the g of x plus h into a g of x and factor it. We can't quite do that, but we can certainly turn g of x plus h into g of x plus some function k of h, where k becomes 0 when h is 0. This is indeed valid, as we could express k of h as simply being g of x plus h minus g of x. Now, with this in the formula, we can expand it out and then perform the factoring described earlier. We can totally bring the g of x out of the limit because it does not affect it. Notice, when we separate the two limits, on the right, we have k of h on top of h, and we already defined k of h to be the difference of g of x and g of x plus h. We will use this in a brief moment. On the left, the remaining limit is clearly just that of the derivative of f of x, and we evaluate the limit on the right using the product rule for limits, where the limit of a product is the product of its limits. So the f of x plus h just evaluates to f of x as the h disappears. In the limit, we have what is the derivative for g of x. And now we could write out our product rule using Leibniz notation. The derivative of f of x times g of x is f of x times g prime of x plus f prime of x times g of x. Let's do some examples to hammer it home, shall we? The first example will be x plus 3 times 4x plus 5. Using the product rule, we clearly separate the x plus 3 into f of x and the 4x plus 5 into g of x. Writing this out, it's the derivative of one times the original of the other, and we do this for each term. Being linear terms, the slope is always the number in front of the x, so the derivatives resolve to 1 and 4 respectively. Multiplying it out and then simplifying, we arrive at the derivative of 8x plus 17. Now this function was simple enough that we can actually try this one out by first multiplying it out and then using the rules we developed in previous videos. Once we obtain 4x squared plus 17x plus 15, we could take the derivative as we normally would using our polynomial rule to take x squared to 2x, using the scalar rule and the sum rule. We arrive at the same answer of 8x plus 17. This just shows that our rule definitely works. Lastly, here's an example where we multiply out three functions, x times x plus 2 times 2x plus 1. This can also be tackled by our rule by setting the first function equal to f of x and all the other functions, the x plus 2 times the 2x plus 1, combined as g of x. Now we could do our product rule as we normally would, except we have to use the product rule again when we compute g prime of x, the derivative of the g term. Let's just expand and then simplify our results, and this leads us to our final derivative of 6x squared plus 10x plus 2. In general, the derivative of a bunch of products is just the sum of the terms, where one of them is the derivative version. So f of x times g of x times h of x will turn into, after differentiation, f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. So for each of the terms, the prime only shows up once. That's a wrap for this video, and until next time, keep on learning.